few of the functions. He is attending majority of the functions. So he is student of this institution. Somebody told he is not. He is student already taking very active part, at least from last 1 year. Thank you very much.
Than anything else. I will try to conclude by the time lunch is served so that we can be back on time and hear the important papers from 2 o'clock. I said I never learned the power electronics or drives. So I don't know what I have to say. But the Chancellor said that I'm grandfather. So I will give you how my generation gave you the concepts of power electronics and drives. My generation gave you this concept. Okay? It's crawling. Now, if the parents keep a bright object in front of the child at a distance, then the child has to crawl faster. Or if the child gets tired, then the child has to slow down. This bright object sends the signals to the brain of the child, and the brain sends the signals to the force. If the child is tired, and the brain says go slow. And this is akin to the basic inverter where we have 4 switches arranged in a bridge topology, and these switches are controlled by gate pulses generated. So that is our generation. The second one, in the second one, what we did is we gave you the concept of body temperature or environment temperature, and the room temperature sends the signal to your brain, and the brain sends the signal to the hand so that you can use the fan control the fan and the speed of the fan. And this is the concept our generation gave it to you. I'm just telling you all used in developing the inverters. The third concept is this. This is akin to the switching pattern of the inverter. In an inverter, 2 switches in opposite arms of the bridge conduct and the others remain off. And the rhythm of beating those pastels into the motor is such that only one hits the motor and not the other one. And same thing happens where in the inverter, when we similarly in the inverter, no 2 switches on the same leg can turn on once because it will be a short circuit, right? So all these concepts all of you have used in developing the inverter technology and power electronics. And the last one relates to my experience. And this is one where we control the speed of the material that is being ground, and we use our hands. And then all of a sudden the material inside the hole comes out. And that is called reflective wave. And that's what happened in the beginning with adjustable drives. And all of you have developed things inside the enclosure called drive. And I was not part of that generation. My time is how to use that enclosure in the real-time applications. So we trusted that everything inside the enclosure that is called a drive will work well when we connect it to a pump motor or anything, or a fan or anything else. So I'm not too competent as to what is inside the enclosure, but I will tell you all the troubles that we had as the drives were developed. In the beginning, we call it adjustable speed drives. We did not call it variable speed drives. We call it adjustable speed drives. And small drives were used for the HVAC components, for the fans, ceiling fans, the supply fans, the exhaust fans were small ones. And then came the variable speed drives. We used it mostly for to control the speed of the motor of a pump. And in the beginning, what happened is the motors were a standard induction motor. And when we started using these adjustable speed drives, then all of a sudden we had problems with the bearings of the pump and the motor, and they got burned because of the reflective waves of this of the lower frequency voltage that reached and the heat had generated. And so we had to, in the field, we had to figure out what happened to the bearings. And then came eventually we developed a insulated bearings so that they can withstand the heat of the heat from the variable speed for the lower frequency. Then came the higher voltage and the higher horsepower motors, and mostly we used 480 volt motors for the speed control, and then later came the 4160 volts for the higher horsepower. So we used like for 1000 horsepower pump motors and everything in a 4160 category. And the largest one that I used was the 2000 horsepower motor, and it takes totally different technology. And in 480 volts motor, then we realized that we need to have input filters when we keep the variable speed drive close to the power source. So we started using the input reactors so that we can diminish the effects of the surges in the incoming power. And then what happened is then we realized as the distance goes between the variable speed drive and the motor, then we have to have some sort of a filter on the output. So we started using the reactors on the output also. Then came the applications of the submersible pumps, which were way deeper, like 2,000 feet, 3,000 feet into the ground. And then we had to figure out how to control without destroying that pump because it would be very costly to remove the pump and refilters on the output side of it. And then we use regular filters on the input side of it. Then came the new generation of the variable speed drives where the reactors were built into the VFDs, so we didn't have to use an external reactors to have on the input side or on the output side. So we are struggling how to use the box created by you in the real world and in the real applications. Always there are challenges in the field because the electronics quite don't understand as to where it is being applied, and we have to come up with solutions to that. And that's what has been my experience in the last 40 years, is how to use these smart electronics that are inside a box. So that's my experience, and we still have a lot of challenges. A lot of manufacturers, variable speed drives don't work after a while. And then we had to find another manufacturer. We had Rockwell, and had the Allen Bradley inverters. Now we are using Square D inverters, and we are so that we can provide drinking water or to even pump the wastewater out of the treatment plant. So it has not been an easy thing for us to use the variable speed drives. In concept and in paper, it looks marvelous. But in the field, it is totally different issue. The heat generated by some of the biggest variable speed drives is also a challenge. And the environment that they are in is limited to some 100 degrees Fahrenheit. So we have to cool the rooms. If we don't cool the rooms, we destroy the life of the VFD, and then we have to replace that expensive VFD. So in the applications part of it, there is a lot more challenges to the drives than what we know when we are just presenting the papers on it or doing the improvements on the VFD. But when you improve in smart electronics and variable speed drives, understand the environment that they will be used for and understand the applications that they will be used for and talk to people like us as to what we went through so that you can come up with the better solutions and better VFDs. And we are still looking for a manufacturer who has the greatest VFD. We have been switching from manufacturer to manufacturer on project to project. And now, literally, we have so many pumps on variable speed drives because we are trying to match the supply and the demand in terms of water. And we don't want to pump more water, we don't want to pump less water, we don't want to store in the storage tank because that becomes stale within 24 hours we have to use. And once we are using the water in the storage tank, then we have to slow down the pumps in the treatment plant. So there is a lot of creativity involved in using these variable speed drives. And I'm lucky in a sense, I know the sanitary engineering part of it, which I did a master's on, and I know the electrical part of it because I did a master's on it. And I'm running a business because I also studied the MBA. So I'm lucky that I have knowledge of all the three phases of it. And I just wanted to convey to you as you do the research, as you study, look at it creatively and talk to the people who are actually using that drive and see what problems they face so that you can improve the what is inside the enclosure. I mean, it's no different than when we buy a car. We trust that it will work. We just sit behind the steering wheel and start the car and we hope everything works. But if the tires are not there, then it will stop within a feet. And if the AC doesn't work, then we have a problem. In olden days, we had one serpentine belt in the car that controls a whole bunch of stuff, the pumps, AC, and whole. If that belt is only 150 rupees, but if that breaks down, the entire car is useless. So there are so many things that when we develop, we want to talk to the users and say what experiences that you have with our product. And that gives you the feedback as to what is needed inside the box. So thank you very much. I know I have 4 minutes for your lunch and we want to go back on time at 1 o'clock so that you can eat till 2 and then we have important sessions after 2 o'clock. Thank you very much.
Thank you. Was with a really different perspective of how we can daily life and understand it in a much simpler way. That was really different way of explaining the technical things, and that's where your innovation stands. So thank you so much for that, and for presenting the challenges that you are seeing in your application daily. I
Okay, so with this talk, we'll. 1 second.